am going to explain you RL series circuit. Consider a RL series circuit with resistor of R ohms and inductor of R Henry connected in series. This is given supply with a voltage source of V volts. A current of I amperes starts flowing in this series circuit, because of which a voltage drop of VR takes place across resistance R, and a voltage drop of VL takes place across inductor of L Henry. By Ohm's law, we can write VR is equal to I into R. Also, VL can be written as I into XL. The total voltage V is equal to V bar is equal to VR bar plus VL bar. This is a phasor addition. In order to find out the total voltage, we will have to draw a phasor diagram. Let us develop a phasor diagram for this case. Here, current is common for the resistor and the inductor. So, we will consider current as the reference phasor. For resistor, we know that the voltage across resistor, that is VR, and current flowing through the resistor I, they are in phase. So, we will have to draw VR along the current phasor. For inductor, the voltage across inductor and current are such that current lags behind the voltage by 90 degrees. So, we will have to draw VL such that this current lags behind the voltage. So, VL is drawn leading this current by 90 degrees. To find out the total voltage, we will have to add VR bar and VL bar. For this, we will draw one parallelogram, and the diagonal of this parallelogram will give us the total voltage. So, let us draw this parallelogram. The angle between the total voltage and total current is angle phi. This is the phase angle. The power factor of this circuit, cos phi, is cos of the angle between voltage and current. Here we observe that there is one triangle which is formed here, with one side as VR, the other side as VL, and the third side is V. Let us draw this triangle again. This is V, this is VR, and the vertical side is VL with this angle phi. This triangle is called as voltage triangle. If we divide each side of this triangle by current I, we get this VR reduced to R. This side VL, if it is divided by I, it gets reduced to XL. And if you divide V by I, this side gets reduced to Z. Z is nothing but the impedance of the circuit. It is the total opposition offered by this RL series circuit to the current flowing in this circuit. This Z can be written as Z is equal to R plus JXL. This is a complex number, but we are not using complex operator I because we are using I in order to represent current. So, J is considered as the complex operator. This form of representation of Z is equal to R plus JXL, is called as rectangular form. In polar form, we can write Z as Z is equal to modulus of Z at an angle phi, where mod Z is given equal to under root of R square plus XL square, and phi is written as tan inverse of XL upon R. here we see that the current is lagging behind the total voltage. So we say that this phi is lagging and the power factor is also lagging. Now let us write the equations for instantaneous values of voltage and current for RL series circuit. If we observe this phasor diagram, the current is seen to be lagging behind the voltage by an angle phi. If we write the equation of V as Vm sin omega t, for current which is lagging behind this voltage, I can be written as I is equal to Im sin omega t minus phi. Now let us derive the expression for the power consumed by RL series circuit. For this, we will have to refer to the waveforms of voltage and current flowing in the RL series circuit. It can be seen that the voltage waveform starts from theta equal to 0, whereas the current is lagging behind the voltage by phi radians. So the current waveform starts from theta equal to phi. Now between 0 to phi, power is negative. From phi to pi, power is positive. From pi to pi plus phi, again power is negative. From pi plus phi to 2 pi, power is positive. This is the average power line. Now let us find out the mathematical expression for P instantaneous and P average. Instantaneous power is equal to the product of instantaneous voltage and instantaneous current. After substituting the expressions for instantaneous voltage and current in this, we get P instantaneous is equal to Vm sin omega t multiplied by Im sin omega t minus phi. This is equal to Vm into Im into sin omega t into sin of omega t minus phi. This is equal to Vm into Im into cos phi minus cos of 2 omega t minus phi whole divided by 2. This is equal to Vm Im upon 2 into cos phi minus Vm Im upon 2 into cos of 2 omega t minus phi. It can be seen that the second term is a cosine term with double frequency component. When we want to find out P average, we will have to integrate the expression for instantaneous power over a complete cycle, and then the average value for the second term becomes 0. So P average is equal to Vm Im upon 2 multiplied by cos phi. This can also be written as Vm upon root 2 into Im upon root 2 into cos phi. Vm upon root 2 is Vrms, Im upon root 2 is Irms. So P average is equal to V into I into cos phi.